Hello folks, today we're going to have a look at my little Atlas 7A shaping machine. I've just got it all sorted out now. I've got the vise fitted, I've made various adjustments to it, I've got new belts, I've put a brand new motor on there, repaired one or two things. We've also got an inverted drive now, you can see that to the rear of the machine. And it's got all the controls that we need. I'll just show you that. There you go. Alright, this is a nice little machine. It's an old one. It's not the common one. The most common one is a 7B, which had some improvements on it. This one has actually got a number on here, which is 514. So I'm presuming that this is machine number 514. I'm not sure. But anyway, I thought I would just show you this thing running. You can see I've cobbled something up here with the cables. When the electricians come to do all the testing and things, I'll get them to sort all that out properly. But it's safe at this moment in time. When you buy, this is a Newton Tesla unit here. When you buy that from them, that's already pre-wired. So is the motor. The motor came from Newton Tesla too. That's all pre-wired. You don't have to do anything with it. So it's already been tested and sorted out. But anyway, let's have a look what we're doing here. We've got a block of steel in the vise, and this block of steel is about 1.25 inches wide. I've got this machine set up at the moment for a 20 thousandths feed cut. Now on the shaping machine, a bit different from this machine to my right here, which is a metal working planer. On the metal working planer, the work's attached to the bed and the table, where the table moves backwards and forwards, and the cutting head moves side to side. On the shaping machine, it's the opposite. The work is attached to the table, and the table moves side to side. And the tool itself, which is here, that reciprocates backwards and forwards. So it's different. Obviously you can see you do much bigger work on the planer, the metal working planer, than what you do on the shaper. Shaping machines came in all kinds of sizes, anything from a couple of inch hand operated up to 36, 42 inches stroke, and some even bigger than that, especially at shipyards, railway works and things of this nature, where there would have been specialist machines built for specific purposes. This is actually a column shaping machine. You can see that it's built, everything's built on a column, an iron column in the middle here. There are other types. You can get a draw cut shaper, which is a very heavy duty machine. It cuts on the rear stroke only. And there are travelling head shapers as well, where the head would move sideways as it was reciprocating. There were reasons why you would use that against the more common one. But this here is a simple, straightforward column shaping machine, or metal shaper. Very nice little machine. It's working nice now. I'm going to set this, I'm going to show you a cut here, and we're going to take off, if I can read this correctly. I'm just going to get me magnifying glass. Here it is. And we've got, well, that's about 33 now, so we'll put, it's 40, 50, 33, that's about 53 now, so we've got easily 20 thousandths on there. I'm going to leave it at that. Got it set for 20 thousandths depth of cut that way, and I've got it set for 20 thousandths step over. Now, because of the Whitworth crank return mechanism in here, which drives the ram, what we do is we feed only on the back stroke and we cut on the front stroke. The back stroke has got a lot of leverage acting against it. You don't want to be cutting on the back stroke on these type of machines. You'll see inside, as that bull wheel is running, the gear wheel is running, the pivot pointer is here for the ram, and that moves up and down in the slide. And what will happen is when you come over that 90-degree point there and you move towards top dead center, you've got more mechanical advantage. So that's pushing forward, so it would travel like that, push forward, and as it came to the end of its stroke over here, it would be down here somewhere, just slightly off center, but it'll be on this quadrant down here. But you've got a lot of leverage acting against this, so all we do is we just use that for returning the ram, and it returns fast. So you can always tell if you got your ram and your motor and everything set correctly, the correct direction. It's slow forward and it's fast return. Alright, let's put the cover back on. I won't go into too much detail about some of the things I've done yet. We'll actually show, we will show a cut. I'm going to put some oil, in fact, find my oil can. Where's it hiding? Here it is by the lathe. We're going to put a little bit of oil on there. Always helps. And we're going to start this thing off. I've got the ram stroke set, position set, everything set on here. Let's just make sure we are going to clear. No, we're going to move it across a little touch. Always important to check before you switch it on. Alright. There you go. Shut it up. Right, let's get it started. There, if you can see the motor pulley just turning away slowly there. According to this, we're only just on jog, which is going to be what, 100 RPM, something daft like that. Alright, we're going to engage the clutch now when it's really slow, and then we're going to speed it up. And I found with this stroke rate here, 1000 RPM is good on the motor. That's a nice little speed there, look. Quite straightforward. And what we're going to do is we're going to feed it and we're feeding to the right, as we should be. So you can see it there, look, starting to cut already. You can hear it cutting, and you can actually hear the chips falling on the floor as well. And you can see the ratchet mechanism. The feed rates on this are adjustable through this mechanism here, and they are between 5 and 25 thousandths. We've got it on 20 thousandths at the moment. And you can see that's cutting nice, that is now. And that's the correct tool holder as well for the Atlas Shaper. And you can see the cutting tool itself is at the rear of the tool post. That's so under heavy cutting conditions, if there's any overload, the tool will bend away from the work and won't dig in. Gives you a much smoother finish. I timed this yesterday and it took 2 minutes 22 seconds to get across the work, which I thought was quite reasonable. I'm in no rush here. I've retired, I'm just working on my own projects, model engineering, things like that. I'm not working in a production environment. But you can actually see that surface finish from here, it looks pretty good. We've got that tool set right, we've got the feed set right, the speeds, everything's right about that now. That's looking quite nice. Yeah, that's great. There we go. Disengage the feed. And what we'll do is we'll slow it down. And when it gets back to the rear position, we disengage the clutch and we switch it off. And there we are, that's it done. I don't know if you can see can you see the shaping machine lines in the work? Typical of a shaper, that is. Seeing a lot of old machines and equipment, steam locomotives and things of that nature. I see a lot of components with straight lines with the machine finish on there. That was done by a shaper or a planer. Okay. Alright, thanks for watching. Bye.